Thank you for joining this lesson. We're going to discuss physics paper 2, the Kcse 2024 examination. Remember to subscribe, remember to share, so that your friends may also benefit from the broadcast. So I go directly to post the paper so that you may follow. We'll be doing the section 1 in this live broadcast. Then later, we'll be having the section 2. The paper 1 has already been uploaded. You can take time and see what we have already discussed. Number 1, this is section 1, whereby we are advised to answer all the questions in this section in the spaces provided. Figure 1 shows the image formed by a plane mirror when an object is placed in front of the mirror. So we have the object, then the image on the other side. We can see the mirror. This one is the mirror. This one is the mirror. Then we can see object and the image formed. Apart from being virtue and of the same size as the object, state other characteristic displayed in the figure. Therefore, ours is not even to recall. We are just supposed to observe, and we just state what we can observe about the object. Okay, about the image formed. So we are already restricted. The image is virtue, and the image is the same size as the object. So those two are the diagram. You discover that whatever is on the right here now becomes the left, and whatever is left here now goes to the right. A mirror after reflection to show the right being on the left. Actually, even yourself, when you stand in front of a plain mirror, you discover that in case you raise your right hand, the image in the mirror is going to raise the right hand. If you raise the right, it will raise the left. If you raise the left, it raises the right, meaning that there is lateral inversion. Therefore, the image is laterally inverted. One property. The image is laterally inverted. Laterally inverted. There might be other properties, as you can see. It is usually equal distance. Where the object is placed from the mirror, the image is formed at an equal distance but behind the mirror. Therefore, we say the image is far behind the mirror as the object is in front of the mirror. That's another property among others. Let's look at number 2. A student observed that when removing a polyester sweater, a cracking sound was produced. Explain this observation. What is leading to the production of a cracking sound? Actually, there are also some like sparklings. Some sparks tend to be produced. And this is due to electrostatic. Other charges in the air. During the discharging, a lot of energy is released, and that is why we hear the cracking sound. Some light, which is in form of sparks, is also produced. Therefore, we will say that during the removal of the sweater, electrostatic charges are created. Let me write this one well. Charges are created. on the sweater, the polyester sweater. The charges in the air produce the sound, produce the cracking sound. Or as they neutralize with the charges formed on the sweater. Therefore, it is a so during the discharging now, a sound is going to be produced. Thank you for following. Kindly remember to subscribe to this broadcast. Remember also to share the link with your friends. Remember that our consultation line is usually 0704 153366. This is our consultation line. You can reach out, or maybe for revision materials. Number 3, explain what happens to the potential difference of a charged parallel plate capacitor when the distance of separation between the plates is reduced. What you're supposed to know is that when you bring the plates together, that is reducing their distance of separation, then the capacitance is increased. And capacitance increases with a decrease in the potential difference. So we say that the potential difference is decreased. The potential difference decreases or reduces. Now, reducing the potential difference increases the capacitance. You should know that capacitance is usually given by Q out of V, where V is the potential difference. Yeah, where V is the potential difference. Then with that, we can now say that hence increase in decreases automatically, decreases the potential difference. It will be an automatic process because we can see from the relationship or from the equation, then these are inversely proportional quantities. They are inversely proportional. Yeah, so we continue learning. Let me remind you of our services here. You can access airtime of any amount for any network from your M-Pesa. You just go to M-Pesa, Lipa na M-Pesa. The paybill number is displayed as 737356. Then the account number is the phone number that you'd like to purchase airtime for. After you've entered the amount, after you've entered the paybill 737356, account your phone number. Then now you proceed to the amount, you complete the transaction, and you receive airtime instantly. Invite your friends to the same. Looking at how to state one advantage of using a circuit breaker instead of a fuse in domestic wiring system. The two are used for the same, that is safeguarding electrical appliances from excess currents. But now we are saying that a circuit breaker has an added advantage. I will give two. Yeah. One of the, I can see people are following kindly. Continue doing the same. You can even share the broadcast so that you may invite a friend. Thank you so much. Yeah, I can see you are seriously following. I can see somebody mathematics question. We'll be having mathematics sessions very soon. But already in my channel, there is what you are asking. So when you go to the channel, you're going to find almost all the topics in mathematics and physics. You can as well start equipping yourself before you get to my WhatsApp to consult. You know, my WhatsApp is so you can inquire more. But already there is some good substance already uploaded. One advantage of a circuit breaker is that a circuit breaker can be for use. So after it has served the purpose, it can be reset for use. It can be reset, sorry. It can be reset for use again. It can be reset. But a fuse has to be altered. It has to be replaced. We cannot reset it for use again. A circuit breaker breaks the circuit instantly. Immediately there are excess currents. The circuit breaker disconnects the circuit instantly, while a fuse takes time to melt. So the circuit breaker disconnects the circuit instantly, while the fuse takes time to melt. It takes time to melt. Yeah, let's look at number 5. We are still continuing. Number 5, the question is saying that a student is provided with a steel needle and a copper coin. Describe how the student can be or can use bar magnet to identify which of the two materials is magnetic. So to identify a magnetic material, you have to use a permanent magnet. Therefore, what the student is going to do is, this student is supposed to bring the two materials one at a time near the magnet. Bring near a bar magnet, or near a permanent magnet. Near a magnet. Then once you've done that now, okay, one at a time. One at a time. The one that gets attracted is magnetic, while the one that does not get attracted, that is not attracted, is non-magnetic. So a magnetic material, by definition, is simply a material that can be attracted by a magnet. We are on figure 2, which is number 6. Figure 2 shows an object O and its image I as formed by a concave mirror. A concave mirror is also called a converging mirror. A converging mirror. Yeah, that is the other name. Now, the question is asking us to complete the ray diagram and indicate the focal length of the mirror. We just indicate what is focal length of the mirror. We're supposed to be knowing what focal length is. We're supposed to be knowing how ray diagrams are drawn. In other words, from the tip of the object, how do rays behave once they hit the mirror? And we're supposed to know that one of the major rays is a ray which is close and parallel to the principal axis. So if we draw a ray close and parallel to the principal axis, a ray close and parallel to the principal axis, this one now is usually reflected through the F. But now that we don't have the F, but we have the tip of the image, then as it passes through F, it will connect with the tip of the image. Therefore, through the tip of the image, then we will have our implied F. Therefore, F is going to be here. This is the principal focus, F. Let me write it well. So point F is going to be at that point. And now that we have the point F, then next is to say that from F to where the mirror is, from F to where the mirror is the distance that we call F to the pole of the mirror. We call it small letter F. Yeah, the focal length. Focal length. So that is what you're supposed to know. Okay, there might be other approaches. There might be other approaches because the ray is not one. The ray is not one. Let me show you what I mean. But again, we can say a ray from the tip of the object through what we call the center of curvature, capital C. Such a ray is usually reflected back through the same path. And so, if I elongate, for example, if I elongate my mirror that way, then I take a ray which connects the two tips that way. Then we can argue that has gone through C, and it is also getting reflected through the same path. So with that kind of an analysis, then we will call this one our capital C. Now with capital C, we have to divide it by 2 because this is going to be the radius. It's going to be the radius of curvature from the pole to where C is. This one will be called the radius of curvature. Therefore, at the mid of the radius of curvature, now we will have another distance that we are calling F. Therefore, the F can also be identified in such a manner. Yeah, in such a manner. Number 7. And I hope people can still remember our consultation line 0704153366. Yeah, that's our consultation line. Using domain theory, explain how electric current produces a magnetic effect in an electromagnet. Remember that an electromagnet is a magnet which has been created in a conductor which is carrying current. Because when current passes through a conductor, then magnetism is created or magnetism is induced. Something that you're supposed to know is that a conductor is just a magnetic material whereby the dipoles are misaligned. When they are misaligned, there is no general magnetism there. Therefore, we can say that The passing of the current produces a magnetic effect which aligns the domains in the conductor, and hence it becomes magnetized, and such a magnetism which is produced by an electric current, such a magnet will be called an electromagnet. We call it an electromagnet. Therefore, we say very fast that the electric current induces an EMF, induces a magnetic effect which aligns the dipoles, of the magnet or of the electromagnet, the dipoles of the conductor, leading to an electromagnet. Because now the conductor will be no magnet, leading to an electromagnet. We can talk about number 8 now. As I remind you of our program here through M-Pesa, you just go to the M-Pesa, Lipa na M-Pesa. The account number is the phone number that you'd like to Safaricom line, Airtel line, Telcom line, as long as it's functioning in Kenya. You just enter that number. Then after that now, just proceed with amount. You complete the transaction and you're going to receive the airtime instantly. Make sure you refer a friend. Number 8, state the meaning of the term periodic time of a wave. This is the time taken by a particle to cover a complete oscillation. To enter or to cover a complete cycle, a complete wavelength. Yeah, such a thing. We are at number 9. We are still moving on. Remember to subscribe. Remember to check on us. Let's know where you are watching us from. Let's know where you are following us from. Otherwise, thank you so much. Number 9. Explain why sound energy travels faster in a metal block than in water. Something you're supposed to know is that sound travels through the mechanism of a vibration of particles. That is why sound is not transmitted in vacuum, because in vacuum there is no matter, where the particles in the matter vibrate and transmit energy. Therefore, we can say that the molecules or the particles or the atoms, the particles making up the metal block, are closely packed. The particles making up or making the metal block are closely packed. Closely packed. Hence, sound is transmitted. Sound is transmitted effectively from one particle to another. From one particle to another. In water, particles or molecules. Even if they are closely spaced, it's not like in the metal block. Widely spaced, widely spaced. In other words, you can also talk about the densities. You can say a metal block is denser than water, and the denser a material is, the closer the particles are packed, and the better they can affect one another when one vibrates due to sound. So transmission becomes very efficient. Yeah, transmission becomes very efficient. At number 10, whereby we are taught to state the meaning of the term refractive index of water. Refractive index of water is the ratio of the speed of a ray of light. It is going to give us of water. Actually, find refractive index in very many perspectives, because we can also talk about this is the reciprocal of the sine the critical angle as light traverses from air into water, because water is denser. Therefore, at the time where the, the angle of refraction in water becomes 90, then the incident angle in air is going to be called the critical angle. So the refractive index can also be given by 1 over the sine of c, whereby small letter c is the critical angle. We can also use real and apparent depth. If you put something in a water medium, then you observe keenly, you discover that the real height, therefore, when you take the ratio of real depth divided by apparent immersed in pure water or transparent water, then such a ratio is also going to give us the refractive index of water. Figure 3 shows a cell connected to a bulb, a switch. A cell connected to a bulb and a switch. These ones are connecting wires. Should be in a position to label every component in a circuit diagram. When the switch is closed, the bulb lights. Explain cell drives the electrons in the circuit. Therefore, you talk about the potential differences it's going to create. That is what will lead electrons from flowing now in the. So when the switch is closed, it's the cell which pushes electrons, and hence the flow of current. An electric bulb is marked 60 watts to energy the bulb consumes in 1 minute. Determine the energy the bulb consumes minutes. We know that power times time, that is electrical energy or heat energy, yeah, caused by an electric current, multiplied by 1 minute, which is equivalent to 1 times 60 to make them SI units. 3600 to talk about joules. But there might be several alternatives of working this one out, whereby we can say alternatively, power is given by voltage times the current. Therefore, we're supposed to tell ourselves that the current is going to be given by power over V, which is 60 out of 240, which is 0.25, yeah, amperes. And now can see that energy is given by, instead of P, we use VI, then times T. So it is 0.025 multiplied by time, 60 seconds. This is going to give us VIT. Sorry, we need to begin by V. I is current, T is 60. This is going to give us 3600 joules. We are just playing along with several relationships of these quantities provided here. So you can even continue until you involve resistance according to Ohm's law, and you shall get the same answers. Number 13, as we wind up with section 1, we are told to state what is meant by long-sightedness as an eye defect. We know that the main eye defects are only two: long-sightedness and short-sightedness. So long-sightedness is whereby the eye, or the lens of the eye, focuses far objects at the retina, while we'll say that near are focused beyond the retina. Focused beyond the retina. Yeah, they are focused beyond the retina. You find that now because the screen where images are formed for objects. Therefore, if the rays are converging beyond the retina, then it means there is a problem. We have the short-sightedness, whereby near objects, their images are focused at the retina, but distant objects, their images or rays meet before the retina. Those are both defects. Now we are to explain how long-sighted a converging lens. The lens converges the rays of a far object as though they are from a near object. So they are from a near object, as though they are from a near object. So that is it. We'll be continuing with this paper, the section 2. Remember to subscribe to this platform. Remember to share the broadcast with your friends. Remember to check our uploaded lessons, which are really going to help you. Yeah, remember to follow our program here, whereby you can access airtime of any amount for any network, be it Safaricom, be it Airtel, be it Telcom. As long as you are operating from Kenya, just purchase any airtime. The pay bill number is 73 7356. The account number is your own.